In this video, we'll look at question A13 and A14 of Science Paper 1, 2022. A13 reads, the following diagram shows a steel bar being made into a magnet using double touch stroking method. Which diagram shows the magnet made? So, by the use of stroking method, you should know that the magnet made is going to have opposite poles of from the magnet that was used to make it a magnet. So what I'm trying to say is that, so for this one is not a single touch but double touch from the question. So in these rotations, right, in these stroking rotations, this north pole is going to probably end up here, these two north poles, and the south poles will probably end here. This means that at the end of the stroking, you're going to have north pole on the ends of the magnet made, and you're going to have south poles on the ends of the magnet made, and north poles in the middle of the produced magnet. So this leads, if you take your options, you're going to find that the correct answer here is B. The next question, which is A14, reads, the following diagram shows a charged polythene rod which is moved near end V of the metal sphere mounted on an insulating stand. Which of the following diagrams shows the correct charge distribution of the sphere? So you've got a charged polythene rod that is negatively charged, and then you have this insulating stand that has a metal sphere on top of with and W ends. So you should know that every metal has sort of like a sea of charges within it. It has both negative and negative charges inside it, except they are not distributed on one side where you have maybe negative charge this side and positive charge this side. No, instead, for every metal that is uncharged, you're going to find that the distribution of charges positive, negative, positive, negative, positive, positive, negative. So they are evenly distributed. So once you have you bring near a charged rod, such as this charged polythene rod, close to a metal sphere that has charges and evenly distributed inside it, the charges that are opposite to this polythene rod are going to be dragged to one side of the end near this polythene rod, because opposites attract. So if this is negative right here, then the positive charges of this metal sphere are going to action, all of them, not the negative, the positive charges are going to this part of the sphere, because they're attracted to the negative charges of the polythene rod, and then this will leave the negative charges or the other side W of the metal sphere. So when you compare this diagram we have illustrated to the options we have, you're going to find that C, wait, not C, but C is the wrong answer, because C shows that these negative charges are attracted to the negative charges of the polythene rod, and that is not the case, because you know that like charges do not attract. And then B is our correct answer, because B has positive charges on the side V, which are attracted to the charged polythene rod, and the negative charges will be left on the W end of the metal sphere. What about A and D? What makes them not correct? Well, A doesn't illustrate the other side of the charges of the metal sphere. It just tells you to say no, this it obviously shows that this metal sphere only has one type of charge, which is not the case. And it's the same case for D. D shows you that the metal sphere only has one type of charge, which is the negative charges. So our correct answer here is B.